Hey, welcome back to the API report. Today we're going to take a look at the Mistral API to see how good it is. Let's dive in. So, Mistral AI, who are they? They're kind of like Open AI, but they focus on open models instead of the proprietary models like GPT. They've got a nice looking website. How good is their API? Let's go take a look. Come on over to the documentation. It's quite a lightweight API. There's not a lot going on. They've got 3 endpoints. You can create chat completions, create embeddings, or you can list the available models. We're going to start with listing the available models. So it's a simple get request to /models, and it returns a 200 response with some JSON data. It will tell you not a lot, really. It won't tell you much, but it will give you a list of available models. Each model will have an ID, an object name, when it was created, and who it's owned by. Relatively straightforward and relatively simple. There's not really much we can talk about here. There's not as many models available on Mistral AI as there are on other services, but Mistral is very, very good at chat completion. So let's dive into the chat completions. To create a new chat, you would just send a post request to /chat/completions, sending over a JSON payload where you declare which model, the temperature, the top P, max tokens you want to use, whether you want the response to be streamed, do you want safe mode enabled, and are there any random seeds that you might want. Along with this, we send over a list of messages. Each message will have a role and the content itself. So as we can see in the example, we're sending over a message where the role is the user and the content is what is the best French cheese. Quite random, I know. So the different roles would be similar to how Open AI works, where you have a system user and then you have like a chat user. In this case, we have a user role for when you're sending messages, but you can also include like assistant role messages as well. So you can kind of fine tune your prompt that little bit more. The response you get back, unfortunately, we only get a 200 response. It's not giving us the true HTTP status code for when you create something, which would be a 201. It's not telling us how the error states might be structured or how those responses might come back to us. We can make assumptions based on HTTP status codes, but are they following that strictly? It's hard to tell. So the response we get back, we get the ID of the completion that we just created, the object name, which in this case would be a chat.completion, when it was created as a Unix timestamp, which model we used, and the choices and usage. Usage is how many tokens we used, and the choices would be a list of basically completions to choose from. In the example here, we just get the one back, but I'm assuming we would get a multiple. So it's not bad, okay? It could be worse. There's not too much to talk about with this one. There's 3 endpoints. Embeddings I'm not going to dive into because it's just another post request that's going to be much like the same. And if I'm honest, I've got no idea what an embedding is in the context of the Mistral AI. The documentation isn't clear. So if you know, drop it in the comments. I'd love to know. But overall, it's quite useful. So if we have a quick look at like the temperature, for example, what sampling temperature to use between 0.0 and 1.0. Higher values like 0.8 will make the output more random, while lower values like 0.2 will make it more focused and deterministic. That's not awful. It explains it quite well to a Luddite like myself who doesn't fully understand the AI world. So it means that if I want kind of more focused, specific sort of responses, I need to use a lower temperature, a lower sample rate. However, if I want to just kind of throw a wider net, maybe I'm going to increase that temperature to get, more random responses, things that I might not have thought about because I'm not fully on board with that topic yet. Quite useful. So how is it if we use API Insights? Is it good? Is it bad? Let's find out. So I can grab the spec, I can download the spec from GitHub, I believe it was, and it comes in YAML format. I know, YAML. Why do people still use that? If I drop it into the API Insights app, I can see I get an F. Not great. But there's 3 endpoints. Let's talk about some context as we go through this score. We've got a D for design, a D for performance, and an F for security. Now, if we look at the design specifically, we can see they're not doing any rate limiting, there's no consistent pluralization, and they don't have very robust responses. They do use multiple HTTP methods, they've got consistent noun usage, they support JSON, and they do version their API. So let's talk about those failures. If we look at the context of the Mistral API, typically this is going to be used mostly for internal development, maybe not something that you'd put out in production just yet. So they may not want to do any sort of rate limiting just yet. Further down the line, they may rate limit. Who knows? But it's not a public-facing API. It's not something that you just use. Typically when people use AI APIs, they'd go for maybe stability or Open AI. Mistral is kind of like the newcomer at the moment. Very, very good, and they've got a fantastic model. But this is they've only just started to come out into the API world. So we've got to give them a chance to find their feet before we properly rate their API. Consistent pluralization. Again, it's an action-based API. A lot of the APIs I'm seeing these days, they go for more of those action behavioral driven. They're not talking about just kind of CRUD APIs around resources. So it makes sense to me. Robust responses, well, we saw that from the documentation. You're going to fail that if you only ever give me the happy path. Let's look at the performance. Not the worst score. We've got a D again. We've passed 3 out of the possible 5 tests. We're failing on compression and cache, which I can understand. Compression, maybe you want to enable something like gzip or Treblle. That could be quite useful and speed up that API response a little bit faster. But cache, with this behavioral driven approach in the AI world, you're not going to get hardly any requests or responses that are even close to the same thing. Each of them use a different amount of tokens. Each of them use different temperatures, and each of them are going to have slightly different tweaks, completions and chats that they're trying to convert. So they won't have any caching requirement at all there. Response size, you can't tell too much from just an Open API spec and a handful of requests. For that, you would need something like Treblle. And what Treblle will do is it will capture all of the requests and start to give you an average across all of your requests, not just this one was this big, so we assume that all of your API responses are going to be 32 meg, for example. They are passing on the CDN usage, HTTP2 usage, and the load time. So it is a fast API, and they're using a modern standard for delivering that. But they could increase that a little bit better by adding that compression itself. Now, elephant in the room, security. I'm seeing a lot of failures here. We've passed one of the possible 6 tests. We're failing on content type options, failing on content security policy, failing on an AI frame embedding, authorization, and strict transport security. We are passing on secure URLs, but I would expect to see a little bit more when it comes to security around this. At least authorization and strict transport security. The others, I can kind of forgive a little bit more, but those three are the gold standard that you need to aim for. You should have secure URLs. You should enforce strict transport security, and you should always authenticate an API user. Whether it's a public API or not, that should still be authenticated so that you can monitor and maintain your API correctly. What I've not shown you before is the technologies used. So we're actually detecting two pieces of technology that Mistral are using. They're using both Cloudflare and the Kong API gateway. Pretty useful to know. If you're ever thinking about building a similar API, understanding how others approach their infrastructure for their scale is always a great insight to understand their approach and the methodology to keeping their systems available. As you can see, Mistral use Cloudflare and Kong. It's a good combination. So, as always, I like to download the report as a PDF. I'm just going to move that to my downloads and save it. Pretty handy. And of course, what is the point of building this if I'm not going to share it with someone? So I'll share it to my notes. What I can do later on is I can take that URL, I can share it internally, I can share it with friends, share it on Twitter, and start conversations around how could I improve my API? What am I missing? What do you think about this? Is this really a failure? What do you think from a context perspective? Those things are useful when you're building an API to have further conversations. So being able to share a report like this, either in PDF or as a link, is always a valuable thing to do. Now, if you have an API and you're interested in seeing how good your API is, you can download API Insights from the Mac App Store or use our web platform at apiinsights.io. And pretty soon, you'll be able to use our CLI implementation, where from your command line, you can quickly and easily test your Open API specs without leaving your editor.